Let's talk about some of the other renewable energies that are not included in Nobody's Fuel. OTEC, for example, Ocean Thermal Energy Conversion, where this is the system that uses the difference in temperature between water at 1,000 or 3,000 meters in the ocean and the surface, and it might be as high as 20 degrees Celsius. This is this can actually be made to work. It's very inefficient and requires large volumes of water, and it's located only in certain parts of the earth where you can do that. It's very small. It's always going to be small because it's very difficult, and it's far away from wherever you want to use it. People talk about tidal energy. Yes, we can use tidal energy where the tides come in and out every day, but they're not there when you want them, and they're small. And the same thing about wave energy. It's not always there when you want it, and it's relatively small too. And tidal energy, where you put a propeller in an ocean current that flows back and forth every day, it comes and goes. It's very small. These are all small potatoes. They're not anywhere nearly the size that we need to have them for the amount of energy we use. And just to put it into perspective, the world uses 388 exajoules of fossil fuels. And that's only part of the 457 exajoules they used in 2005. An exajoule is a very large amount of energy. It's the amount of energy in 28 billion liters of gasoline. That's about 7 billion US gallons. It's a lot of energy. That would fill the tanks of 500 million cars. So we're talking a lot of energy. So when you're talking about a little bit of tidal energy, that's peanuts. You're talking about OTEC, that's peanuts. When you talk about wind, it's really peanuts as well. And same with solar. Sure, there's enough solar falling on the earth in 1 hour to power the world for a whole year. But it doesn't come when you want it, and it's very difficult to collect. Let's talk about geothermal. There was only one geothermal, that was volcanic geothermal, until ground source heat pumps came along. And now people are saying those are geothermal, but they're not really. Geothermal, volcanic geothermal, applies to heat generated by radioactive decay in the center of the earth. Ground source heat pumps really use solar energy because they only work in the top few feet of the Earth's surface, and that's what's affected by sunlight, for example. The Alberta electricity supply company called ENMEX recently issued an order saying that they weren't going to build any more wind farms for a while. Only 4% of their electricity comes from wind, but it's already enough that it causes problems. Wind is very intermittent and erratic, and it causes the system to collapse because it disturbs it, it upsets things, and the system collapses. So Alberta has put a hold on wind farms until they can build a brand new 1,200 megawatt gas-fired turbine electric generating station. They need that up and operating to be the backup for the wind farms. Remember, wind can't stand alone. It always needs a helper because it only delivers wind 35% of the time. And that's in Alberta, and that's mostly everywhere. And so when they get the helper up, then they can use some more wind. So when you build a wind farm, you always have to build a helper. Let's talk about electric cars. Who killed the electric car? The battery killed the electric car. Electric cars came into vogue 100 years ago, a century ago, and they ran out of vogue because the batteries didn't have enough capacity. The range of the car was not enough. And that's the same problem that they have today. Even though the batteries have 3 times the capacity, the battery in your car holds about 50 BTUs of energy per pound. A nickel metal hydride battery has about 100, and a lithium battery has about 150. So it's about 3 times more capacity than previously. And then it depends where the electricity comes from. If it's from a coal-fired station, all you've done is removed carbon emissions from one point to another. Now, electric cars and hydrogen-powered vehicles are probably a good thing in a city that's very polluted. Maybe someday we'll be able to solve that pollution problem, but in the meantime, it might be a good way to protect people's health, even though overall carbon emissions and pollution has gone up someplace else. When we talk about energy density, we also need to talk about ethanol and gasoline. Ethanol is not a really very good fuel. A gallon of ethanol has about 3/4 of the energy content of a gallon of gasoline. So when you start diluting gasoline with ethanol, then you're going to reduce the fuel efficiency of your car. Less miles per gallon. The world is trending to be more democratic. More and more places are becoming democratic all the time. And that has an implication for energy. For example, in China, when they built the Three Gorges Dam, they had to move 1.2 million people. They could do that because that was an authoritarian state and people were just turfed out. That couldn't happen here. Or if they did, it would be very difficult. It's not the kind of thing that happens in a democracy. And the same thing happened in Cuba. When the oil embargo was put on in Cuba, people just went without oil, and they could do that because that's a totalitarian state. They just legislated who was going to get oil and who wasn't, and that's it. It's a little more difficult in a country where there's freedom and people have the choice to use energy in the discretionary ways that they like. And people do use energy in a discretionary way. Some people have four-wheeled SUVs and some people have four-legged SUVs. These are discretionary ways of using energy. Not that I'm promoting an SUV car or I'm against SUV dogs, but everybody is part of the problem. I'm concerned about the environment, critically concerned, and that's why I've presented Nobody's Fuel. I'm also concerned about climate change. I know that if there's not enough energy, we won't be able to help people. If their lands flood or if there's a hurricane or whatever, we need lots of energy to be able to help people. So I'm concerned about people, about the environment, and about climate change. And so I've done something about it. I've done a careful engineering analysis of what the world's energy system is about and what we have to do to have enough energy to help people out of poverty, to maintain the well-being of people, to protect the environment, and to adapt to climate change.